Hello, I'm Farnaz Jahanbakhsh, and this is a presentation of the paper exploring the use of personalized AI for identifying misinformation on social media. I worked on this during my internship at IBM Research, together with my mentors Yannis Katsis, Dakuo Wang, Lucian Popa, and Michael Muller. The spread of misinformation on social media platforms has had a big impact on people's lives and even democracy. And to deal with this problem, social media platforms have risen as the authorities on the truth. It's now the platforms, their machine learning models, their moderators, and third party fact checkers that decide which content is misinforming, and then make the call on what to do with the content. For example, whether to downrank it or take it down. But the centralized moderation of misinformation that is happening on social media platforms is not ideal for many reasons. One being that it limits users' autonomy. Also, a single central decision to, for instance, take down content isn't aligned with what every user wants or needs. In prior studies that I have done, I've found out that some users think they would benefit from seeing unreliable content. For example, because they would be aware of what their friends and family are thinking so that they would know how to talk to them about it. So rather than deciding what content users should or shouldn't see on their feeds, in prior work, I have advocated for empowering users to have a more active role in fighting misinformation. One way this empowerment can be brought about is by enabling users to assess the accuracy of content as part of the data model. With user assessments captured as structured metadata, they can be displayed on content in a structured form as well. And these assessments would have the potential to warn the assessor's social circle if they come across the misinforming content. In fact, another benefit of asking users to assess the accuracy of content is that it reduces the likelihood that they share misinformation. So the bottom line is that I believe enabling users to assess content is a good thing. But there's just so many different sources publishing the same story or posting about similar claims. If a user assesses the accuracy of one of these posts, doesn't it mean that the same assessment would apply to others? And here's where this paper comes in. We design a personalized AI system that scales users' assessments to the enormous amount of content that's out there. The personalized AI takes as training data the assessments that a single user has provided so far and makes predictions on how the user is likely to assess other content that they haven't assessed yet. The AI iteratively retrains itself as the user provides more feedback. Now, how can this AI be useful? Well, such a personalized AI can benefit the user by serving as an aid that conducts a first-pass inspection of the content that the user comes across. In this case, the AI can save the user time by directing their attention to content that they would likely find credible. Or the opposite, it can draw the user's attention to content that they would likely find inaccurate, to ask for the user's explicit assessment on such content. This personalized AI can also act as a guard. When the user is about to share a post that the AI predicts the user may assess as inaccurate, the AI can nudge the user to have accuracy on top of their mind. And if the predictions of a user's personalized AI are displayed publicly, they also have the potential to benefit the user's social circle. So in this work, we explored the potentials and the challenges of incorporating a personalized AI for determining content accuracy on social media. We investigated users' perception of such an approach through a user study. In this user study, we presented participants with a feed of tweets that they needed to assess, and trained a personalized AI model for each participant in real time based on the assessments that the participant provided. The AI that we trained for each participant evolved and updated its predictions as the participant provided more assessments. Our participants had several arguments in favor of incorporating such an AI on social media platforms. For example, they believed that this AI could serve as a first pass filter for them, that it would filter out blatantly false content so that finding accurate content among the rest would be easier. Or that they could use it as a guideline for inspecting content. Some also had reservations about or arguments against adopting such an AI. For example, they were worried that the AI's predictions might be wrong if it were deployed in the wild, or that they preferred to think for themselves, unassisted by an AI. Now, a potential challenge that could arise if such an AI were deployed on social media is that displaying the AI predictions of how a user would assess content may end up influencing how the user actually assesses content, creating a self-fulfilling prophecy. Why is this problematic? Because if the AI mispredicts the user's assessment, it may end up causing the user to believe content that it would assess as inaccurate if they were nudged to think about it. Or the opposite, the user would disregard as inaccurate content that they would otherwise find credible. And in cases where the AI predicts the user's assessments correctly, the influence of the AI on the user can manifest differently. In these cases, by seeing that the AI agrees with their assessment, the user may become overconfident in their assessment. To see if such effects can exist, we designed our user study such that we would be able to compare users' assessments when the predictions of their personalized AI were shown to them versus when the predictions were withheld from the user's view. The experimental setup was like this. Each participant interacted with 3 feeds of tweets. These tweets were all related to COVID-19. We asked that each participant assess all the tweets on each feed as accurate or inaccurate, indicate how confident they were in their assessment, and provide the reasoning for why they believe the tweet was accurate or inaccurate for at least 3 tweets in each feed. Each of the 3 feeds is a step in our experimental setup. We use the data from the first feed, that is the seeding step, to bootstrap the personalized AI model. For each participant, 2 identical AI models were trained in real time, which we refer to as models hidden and visible. You'll find out the rationales behind these names in a bit. After this first step, the participant was redirected to the second step, condition on assisted. To the participant, the feed from condition on assisted looked very similar to the seeding step. In fact, we told the participant that we needed more data from them, so they needed to assess all the tweets on this feed as well. However, the experimental platform had under the hood used the user's personalized model hidden to predict the user's assessment of each tweet on this feed. It's just that the user couldn't see the predictions, hence the name hidden. As the user assessed more tweets on this feed, model hidden evolved, and so did its predictions. After completing condition on assisted, the user was redirected to the third step, condition assisted. In this step, next to each tweet, the user saw their personalized AI's prediction of how they would assess that tweet. The user was tasked with guiding the AI to become better at learning their assessments by explicitly assessing the tweets as accurate or inaccurate. The AI predictions in this step were in fact generated by the user's personalized model Visible. As the user assessed more tweets on this feed, model Visible evolved, and so did its predictions. So now we could compare how users would assess content when they didn't see their AI's predictions compared with when they could see the predictions. There were more nuances to the experimental setup, for example, to make sure that the performances of the 2 models hidden and visible would be similar across conditions. But I'll leave out those details and invite you to read about them in our paper. We found that showing AI predictions does in fact influence users' accuracy ratings. User AI agreements are higher when users can see the AI's predictions. What's more, this effect grows larger over time. So over time, users become more reliant on their AI's predictions. However, this over-reliance on AI is mitigated when users provide reasoning for their assessments. In our study, we didn't see a statistically significant evidence that users gain more confidence in their assessment if they see that the AI agrees with them. In our paper, we discuss how this AI can be deployed in a real-world setting, the challenges that we'll have to overcome then, as well as the ethical considerations around such an AI. I invite you to check out our paper to learn more about our work.